right, good day everyone. We're looking at question 8 part C, January 2021 Csec paper 2. All right, so this one is a speed against time. All right, so let's look at what the question says. It says Monty is cycling at 12 meters per second. All right, after 4.5 seconds, he starts to decelerate, and after a further 2.5 seconds, he stops. The velocity, no, the speed time graph is shown below. All right, so you could see here where he started. That is an initial speed at 12, and it went for 4.5 seconds here, and then it started to decelerate until it came to rest at 0. The first question says, calculate the constant deceleration. Well, deceleration is actually change in speed divided by the change in the time that it took. So what we're looking at now is the change in the speed. Where was the speed? Where is it now? The speed was at, it was at 12, and then it ended up at 0. So we're talking about moving from 12 right here, which is 12, to 0. So the speed went from 12 to 0. So the change in the speed we're talking about, you'd have to subtract. So this is 0 minus the 12, right? The last one minus the first one. Over 7, because this is the last time there, 7 minus where it started. Look, started at 4.5, right? 7 minus 4.5. So this is what we set up to get our information. So we're looking at negative 12 over 2.5. And when you calculate this, we're looking at negative 4.8 meters per second square. So that's the constant deceleration. And for another explanation, it is dropping its speed at a rate of 4.8 meters per second for every second. So it's dropping its speed like that. So after 2.5 seconds, it reaches 0. All right, let's look at the other question. It says, Monty's average speed over the 7 seconds. Well, average speed, the average speed is simply the total distance divided by the total time. So we're looking at the total distance divided by the total time. Now, we would have to make an effort to find the distance. The total time was 7, but the distance was not given. So we will have to work out the distance. However, when we're looking at a speed against time graph, the distance covered under a speed against time graph, we can easily use this idea. The speed, hold on, I'm touching the wrong thing here. All right, there it is. I want that color. Good. So we're talking about the distance covered, should say. It's going to be looked at as the area under the graph that you're referring to. Another way you could put it is, if you can find the area of the plane shape that described the journey, the area of that plane shape is actually equivalent to the distance traveled. So if we find the area of this trapezium, then we will be able to get the distance. So let us go ahead and find it. What's the formula for the area of a trapezium? Quickly. Well, let's look at the distance now. So we're focusing on the distance here, which is the area of the trapezium. All right? So the area of the trapezium is A plus B over 2, which is half the sum of the parallel sides times the height. Parallel sides, one is going to be 7, and the other one is going to be, as you could see here, 4.5. So we're going to add, so it's going to be 4.5 plus 7 over 2, and we times this by the height, which is 12. All right, so let's put together that working out. What are we getting? Putting together all of this, when we work out this, we'll get 5.75 times 12, and that is 69. So that is 69, right? So the distance covered would have been 69 meters. So having that we have the distance covered, we could go back to our formula. Total distance is 69 meters over the total time, which is 7 seconds. So when we divide that through, 69 divided by 7, I will get 9.86 meters per second. So that is the average speed of Monty, right, over the journey. 9.86 meters per second. All right, I hope that you learned something from this. I thank you for watching. Like, subscribe, and share.